All right, guys, we are going to pick up on question 19 where I left off in the last video. First thing we're going to do is read the directions. It says to factor completely. So the first thing we do when we factor is look for a common factor or a common number that goes into all of your terms. So I have 64, 8, 24, and 3. And I ask myself, does 2 go into all of these? No. Does 3 go into all of these? No. And I don't really have to check anymore because the smallest number I have is 3. So I know it's not going to be anything bigger than that. So since there's 4 terms, I'm going to go ahead and group these. So I group the first 2 and I group the last 2. And in this first group, 64a cubed and 8a squared have an 8a squared in common. If I divide that out, 64 divided by a is 8. A cubed divided by a squared is a. And 8a squared divided by 8a squared is 1. Now in this second group, I have a negative, so I know that I'm going to have to pull out a negative number, and 3 actually goes into both of these. So the reason I knew I had to pull out a negative is I need to get a positive 8a, so I knew I had to pull out a negative in order to get that. So negative 24a divided by negative 3 is 8a, and negative 3 divided by negative 3 is positive 1. So now I check, do my groups match? And since they do, I can go ahead and factor that out from each of these. So if I factor it out from here and here, I have to write what's left. And I have an 8a squared minus 3 left. For number 20, again, I always start by asking, is there anything in common? And 16 and 25 do not have anything in common. But I do notice that it's a binomial. So if a binomial does not have anything in common, then the next thing I check is it difference of squares, difference of cubes, or sum of cubes? And this, in fact, is difference of squares. And that's 4m squared minus 5 squared. So that means I'm going to have a 4m and a 4m. That's what is my 16m squared. And I'm going to have a 5 and a 5. And that's my 25. One has to be positive and one has to be negative in order for there to be no middle term. So there is my final answer. For number 21, again, there's nothing in common. So I check, is this difference of cubes, sum of cubes, or difference of squares? And this is x cubed plus 4 cubed. So this is sum of cubes. Now, if we have a cube plus b cube, we are going to have the same sign here, opposite sign here, and always positive. And the formula we're going to use is ab, a squared, a times b, b squared. So using this formula, let's go ahead and plug in what we have. So let's do our signs first. And we have same sign, which is positive, opposite sign, always positive. A in this case is x, so I'm going to put x here, x squared here, and I'm going to multiply by x here. B in this case is 4, so I have 4 here, I'm multiplying by 4 here, and I have 4 squared here. So simplifying, I have x plus 4, x squared minus 4 times x, or x times 4 is 4x, and 16. All right, number 22, look for something in common. I know 3 goes into 27, but it does not go into 125. I can't think of anything else that they have in common, so I'm going to check, are these perfect cubes? And that is 3x cubed minus 5 cubed. All right, now my signs. Same sign as the original question. Opposite sign, always positive. So A is 3x. I'm going to plug that in here. Here I'm going to have 3x squared. here, I'm going to multiply by 3x. My b is 5, so I have 5 here. I'm going to multiply by 5 here, and I'm going to have 5 squared here. So that's 3x minus 5. And then I have 3x squared. So that's 3x times 3x. That's 9x squared. Be careful, because a lot of the times people just put 3x squared. But that's not. That's 3x, the quantity of 3x squared. So that's a 9x squared. So plus 15x plus 25. And there is my answer. All right, 23. Now, let me note that there are absolute values here. So I'm going to recall that an absolute value graph is a V. And I need to find my vertex. So if we recall, we have y equals a absolute value x minus h plus k. So my vertex is h comma k. So notice the negative here, so I have to flip that sign and put a -1. And I have a positive sign here, so I keep the sign of k. So my vertex is at -1, 1. Now my amplitude is that number in front. My a is -1 over 1. So I'm going to find my other point by going down 1 over 1. And remember, v's are symmetrical, so I'm also going to have a point here. And if I connect these and draw my v, here is what I get. 24 says graph the system to solve, or solve the system by graphing. So starting at -3, I'm going to go up 1 and over 2 for my slope. I like to repeat my slope at least twice to try to get a more accurate line. And that's for line 1. I also like to label. So line 2, my starting point, my y-intercept is at 2. And my slope is up 3 and over 1. If I did my slope twice here, I would go off the grid. So I'm going to go down 3. So 1, 2, 3. And back 1, because a -3 over a -1 is still a positive 3. Now, when it says solve the system, we're looking for the point of intersection. So my graph looks a little off, but the closest point to that would be -2, -4. And I can check my work to make sure. So I'm going to plug these back into the original and get -4 equals 1/2 times -2 minus 3. That 2 and that 2, so that's a 1. So is -1 and -3 -4? Yes. Plugging it into the second one is -4 equals -3 times, I'm sorry, that's a -2 there, plus 2. So that's -6 plus 2. Does that equal -4? Yes. All right, the last question is to expand completely. And if you recall Pascal's triangle, the third row is 1, 3, 3, 1. Or if you have Valdez, which most of you guys do watching this video, we're going to do 3, choose 0, 3, choose 1, 3, choose 2, and 3, choose 3 to find our coefficients. And when we do that, we get the numbers 1, 3, 3, and 1. Okay, so I'm going to have 1 times something, plus 3 times something, plus 3 times something, plus 1 times something. We're going to put each of our terms here, so m, 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 and m. And we're going to put our next term, we have 2n, 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 and 2n. Now our exponents start with the highest degree, which is 3, and we decrease, so 3, 2, 1, and 0. Now these exponents, sorry about that. These exponents always have to add up to that degree, so if this is a 3, this must be a 0. This must be a 1, a 2, and a 3. They increase. Last but not least, we do some simplification. 2 to the 0th power, or 2n to the 0th power is 1. So I get m cubed plus 2 to the first power is 2. N to the first power is n. So I'm going to get 3 times 2. 3 times 2 is 6 m squared n. Here, 2 squared is 4. Times 3 is 12. So 3 times 2 squared is 4. Is 4 times 3, which is 12. And I have m. All right, so I have m to the first and n to the second. And then the last one, m to the 0th, is 1. So I have 1 times 2 to the third, which is 8, and n cubed. So there I have expanded m plus 2n all to the third power.